Our mind-blowing lead is way amazing 390 light-years away, as a matter of fact. To put things in perspective, a light-year is the same as 6 trillion miles. Man's voracious interest has driven us to a stunning disclosure that rises above the actual substance of time. The remarkable James Webb Telescope has recently captured a captivating glimpse of a celestial structure that predates the birth of stars, suggesting an object older than the universe itself in a surprising turn of events. The ramifications of this disclosure are enormous, convincing researchers to look for replies to this confounding conundrum desperately. Might how we might interpret the enormous at any point bang be imperfect? What powers added to the development of this strange design, going back an amazing 13.8 billion years? We should dive into the subtleties. Across the huge infinite scope, the James Webb Space Telescope has arisen as a marvelous space test, catching the vast expressive dance of stars and universes and radiating its stunning perceptions to Earth. As of late, it has disclosed a bewildering display, a 13.8 billion-year-old divine construction, testing the actual underpinnings of our enormous understanding. Through this noteworthy mechanical wonder, we wind up faced with a significant vast secret unpredictably woven into the texture of room itself. This stunning disclosure has touched off various discussions and clarifications inside established researchers. Eminent researchers and noticeable observatories all over the planet are continually assaulted with day-to-day inquiries regarding this peculiarity. The most frequently asked of these is, how can the James Webb Telescope detect a structure 13.8 billion years old when the universe is so young? To find out, let us set out on this experience with receptive outlooks, vast interest, and a feeling of miracle that rises above the constraints of our natural presence. On the whole, to comprehend this baffling design, you certainly need to investigate this. In the furthest reaches of the universe, roughly 200 light-years away, dwells a respected star known as HD 140283. This subgiant star, situated around 199 light-years from Earth in the heavenly body Libra, offers dazzling looks into its fierce past, about a long time back. The fact that this star has a particular structure and features does not make it unique. It is likewise an irregularity in time. Picture when our smooth way was still in its outset, acclimatizing a bantam world that once called it home. However, HD 140,283's astonishing age is what truly piques our cosmic curiosity. Its rapid journey is not the only thing that piques our interest. It is one of the oldest stars we have seen, and because of this, it is affectionately referred to as the Methuselah star. Astronomers have been intrigued by this star's age, which is similar to Methuselah in the Bible, who lived for 969 years. Beginning evaluations fixed its age at a stunning 16 billion years. Notwithstanding, the most recent computations utilizing NASA's Hubble Space Telescope recommend a marginally more youthful period of 14.46 billion years, with a vulnerability of 0.8 billion years. This disclosure with respect to its age baffled cosmologists, as the age of the universe, derived from the vast microwave foundation, floats around 13.8 billion years. This problem has brought up significant issues about the star's age, the universe's age, and, surprisingly, the precision of our dating techniques. The James Webb Space Telescope is a remarkable example of human ingenuity that is about to transform our approach to space exploration. Named after James E. Webb, a critical figure in NASA's initial days, this superpowered observatory is taking our space perceptions to an unheard-of level. Intended to recognize infrared light, it can get weak signs from the farthest and most seasoned objects in the universe, giving an unmistakable look into the beginning of the universe. Presently, before we investigate the interesting subtleties of how the James Webb Telescope recognized the 13.8 billion-year-old construction, we should guarantee we're in total agreement with respect to how the period of still up in the air. Astronomical objects' ages can be difficult to determine. For instance, we should analyze stars. They are likened to everlasting lights, keeping up with their radiance, temperature, and size for billions of years, making them trying to date. Space experts use changes in splendor and variety as hints for their age, contrasting these perceptions with models anticipating how stars develop over the long run. One indication of a star's age is its rotational speed. Closely resembling a wheel dialing back because of contact, stars likewise decelerate as they age. What piece of information does the smooth way give to the age of this baffling design? Let us now turn our attention to the captivating dance that is taking place in our cosmic backyard, the Milky Way, in our quest for cosmic knowledge. Late estimations have disclosed an enrapturing scene. Stars dwelling on the external edges of our system show a comfortable, practically drowsy movement contrasted with their partners in different worlds. This disclosure has ignited a grandiose examination, driving stargazers to consider the likelihood that our smooth way may be lacking in a vast fixing known as dim matter. Dull matter, a tricky substance that dodges direct discovery, applies a gravitational effect on heavenly items, assuming a strange part in the grandiose expressive dance. It presents a grandiose riddle that challenges our comprehension. Our cosmic compass may have been out of alignment, and we may have been approaching dark matter from the wrong angle. Enter the Gaia satellite, a heavenly entertainer from the European Space Organization. Venturing onto the astronomical stage and enlightening the complexities of almost 2 billion stars inside our smooth way, Gaia gives exact estimations that force stargazers to reevaluate their enormous dance notes. At the edges of our smooth way, stars seem to embrace an all the more comfortable speed, resisting our past suppositions about their speeds. The speed of stars can unveil captivating experiences into a cosmic system's mass, similar as assessing the size of a group by noticing the speed at which individuals move. Furnished with Gaia's fastidious information, cosmologists have approximated the consolidated mass of our world's gas, residue, stars, and baffling dim make a difference to be roughly 200 billion times the mass of the Sun. Our smooth way, as measured by Gaia's fastidious information, presently shows up multiple times not exactly at first assessed, testing our suspicions about the wealth of dull matter. This disclosure prompts a hypothesis that our inestimable soup could have less fixings than assumed. Gauging a cosmic system, in any case, is likened to endeavoring to try to do something that's simply impossible, a famously difficult accomplishment. Gaia's information might have peculiarities, or our enormous estimating tape might require adjustment. Nevertheless, the cosmic investigation has been joined by a number of research teams that all play the same cosmic tune. Assuming this vast disclosure turns out as expected, it will stamp another section in our grandiose material science course reading, a progressive change in perspective that prompts us to re-examine our smooth way, yet every sparkling corner of the universe. Let's take a cosmic trip back to the 1970s to fully comprehend the significance of this revelation. Stargazer Vera Rubin and her heavenly group set off to translate the cadenced examples of stars in different worlds. Similar to how Neptune leisurely circles the Sun while Mercury races at breakneck speed, the prevalent cosmic playbook suggested that stars on the outskirts of a galaxy would be cosmic slowpokes in comparison to their swift counterparts near the center of the galaxy. Nonetheless, Rubin and her stargazing crew uncovered a vast shock. Stars on the furthest reaches of universes were swaggering their stuff at almost a similar speed as those nearer to the enormous dance floor. This enormous disclosure indicated the presence of a baffling and disguised element, dim matter, the undetectable heavyweight champion that encompasses universes in monstrous radiances. Presently, we should focus in on our vast terrace, the smooth way. Envision endeavoring to monitor everything inside your room while being inside it, an overwhelming errand to be sure. Cosmologists confronted a comparable test, expecting that the stars in the smooth way complied with similar guidelines as those in different universes. For example, our Sun, found roughly 26,600 light a long time from the cosmic focus, circles at a stunning rate of 800,000 kilometers each hour. In 2013, the Gaia satellite was sent off, likened to an accuracy grandiose ruler, carefully estimating the positions and effortless developments of stars in our smooth manner in 3 aspects. It has refined the precision of the data it has transmitted back to us over time, making it resemble a cosmic symphony. Hypothetical physicist Francesco Solocellini and his clever enormous investigators from the Enrico Fermi Exploration Center in Italy recognized unpretentious traces of heavenly deceleration a couple of years prior. With Gaia's most recent information drop in 2022, these clues changed into astronomical firecrackers. The new information is 2 times as exact as the past estimations from 2018, supplying cosmologists with further developed instruments to follow the ways of stars with laser accuracy, even at enormous distances. In the Heavenly Performance Center of 2023, for separate exploration papers disclosed a divine shock. Stars situated up to a surprising 100,000 light, a very long time from the core of the smooth way, give off an impression of being dialing back. Maybe the stars have chosen to raise a ruckus around town, taking part in a smooth downfall suggestive of the planetary expressive dance depicted by Johannes Kepler hundreds of years prior. Conversely, stars in different systems by and large stick to a comparable mood, moving from the middle to the external edges of their cosmic home without a recognizable lull. This revelation has worked up a grandiose tempest of hypotheses and theories. One fascinating chance is that how we might interpret dim matter could require a modification. Dull matter is a theoretical type of issue that doesn't cooperate with light or other electromagnetic radiation, making it undetectable and challenging to straightforwardly recognize. Its presence is gathered from its gravitational consequences for apparent matter. The common model recommends that dull matter structures a tremendous diffuse radiance around universes, giving the extra gravitational force important to make sense of the noticed movements of stars and systems. Be that as it may, assuming the stars in the external locale of the smooth way are for sure